Yeah. Hello, I'm Jan Willemsson from Cybernetica, and I'm presenting challenge area number 5, post-quantum cryptography. So back in early 2023, when I started the project, the world was a very different place because the first post-quantum standards had just been accepted by NIST. It took them like 6 years to build those standards. And then the first versions of official standards had just been accepted, which means that these cryptographic signature and key exchange algorithms hadn't yet made it to any real applications, to libraries, nowhere. So there were just standards on paper, and nobody actually knew how they would play out in the real life. So when we were starting to work on chess post-quantum crypto challenge area, and we were thinking, so what should we do? And the choice was pretty much obvious. So let's try these things out, and let's see how post-quantum transition would actually work out in practice. So our strategic priorities, evaluating the state of the art and practical applicability of post-quantum technologies, which we already knew were starting to evolve very fast at that point of time. And on the other hand, also assessing usability and market viability of these products based on post-quantum algorithms. And as I said, the approach was hands-on approach, taking certain existing infrastructure components, certain existing products, and trying to see how easy or difficult it would be to transfer them into post-quantum crypto, and evaluating this transition along the way. So the first mini project that we're working on is called Aspects of Transition to Post-Quantum Technologies. And this is exactly where we started taking different applications one after another and studying what would happen if we would turn them into or apply post-quantum crypto within them. So the first experiment we made was complete authentication infrastructure, starting from your client device, your key management, using WebAID as an authentication protocol, authenticating yourself to Nextcloud, and including client-side key management device. I mean, you're used to using your ID card, for example, in Estonia, where you have your asymmetric key pairs. So all this crypto is baked into your chip card. Nothing like that existed yet on the market back then. So we had to build our own hardware, essentially, on top of ESP32 microcontroller. And some other experiments we've done. In Estonia, we have this CDOC infrastructure where you can use your national EID to send and receive encrypted messages. So we are still, we did the first experimental implementation, and this project is still ongoing, actually. A big project that we expect to be working on even beyond chess is post-quantum electronic voting, which is something we do in Estonia, and which relies heavily on asymmetric cryptography in many components. So there is a TLS component, there is EID authentication, EID signatures, there is asymmetric encryption, which needs to support all sorts of homomorphic properties, like being able to use mixnets and zero-knowledge proofs of decryption, zero-knowledge proofs of correct ballot and whatnot. So it's a huge bunch of asymmetric crypto that all has to work together, and all of that ideally would need to be transitioned to post-quantum crypto. And there are still theoretical questions to be studied how to do that efficiently. As a very nice side product, there is a library called Lattice Helper, developed by Petr Musikant, who is sitting over there, that has helped us to implement our internal projects. Is very much an ongoing project of its own, and Cybernetica is using it in other projects outside chess as well. The other really cool project is what Brno guys do under the guidance of Jan Heini. And this is a hardware encryptor, how they call it. So the idea is to implement hybrid key exchange on an FPGA-based system and try to build, let's say, a VPN out of it, where on both ends there is this hybrid key exchange capability. So we've done a couple of experiments with this, trying to set it up between Estonia and Czechia. And the next step where they will actually take this FPGA-based solution to Estonia is going to happen early next year. I'm pretty sure Jan will be happy to share all the nitty-gritty details of this. There has been a lot of spillover, so to say, from chess to many other activities that we do. There is, I would already call it traditional future cryptography conference. We've had, I think we've had 2 of these last year and this year. Last year was exclusively post-quantum crypto. This year it was other topics as well, but also post-quantum crypto. There has been a series of PQC workshops. We've had research visits. We gave a special seminar to Estonian State Electoral Office presenting our work on post-quantum e-voting earlier this year, which was very, very nice and successful. Currently, we are working on a number of roadmaps, white papers, reports on post-quantum transition in Estonia, and lots of our experience that we gathered during chess has found its way there as well. And yeah, last but not least, there is this post-quantum project Quark that we just pre-kicked off this morning. And perhaps the I don't know if the most important, but at least the coolest outcome of the project is a board game. So where you can take a role of an engineer who has to implement post-quantum transition of your infrastructure and all the challenges that you may face, like quantum threat is too far away and math is too hard and whatnot. So you can play it out and then see how you would manage organizing post-quantum transition of your organization. I'm not sure it's on sale yet. Better knows no, probably not. But yeah, but they're working hard towards this. So there will be a point where you can actually buy this board game. So yeah, have fun. Thank you.